Hi, I'm Wong from 5Stem1 and my product is biodegradable plastic. It's on the topic for Chapter 10 Environmental Sustainability, Subtopic 10.4 on Green Technology. I will be covering all the learning standards. My problem statement is it possible for schools to practice sustainability by replacing traditional plastic? My proposal is to enforce usage of easy-to-make biodegradable plastic as food packaging in school canteens. So let's get started. For materials, you will need cornstarch, glycerin or glycerol. I use 99.7% glycerin. I got this off Shopee. Water, and distilled white vinegar. For apparatus, you will need a silicone spatula, measuring teaspoons and tablespoons, a saucepan, a tray, and aluminium foil. So grab your saucepan and add 1 tablespoon of cornstarch, 4 tablespoons of water, a teaspoon of distilled white vinegar, and a teaspoon of glycerin. Then mix your ingredients until well combined with a spatula. Next, lay a piece of aluminium foil on the tray. Then, turn your stove on a low fire and heat up your mixture in the saucepan. Make sure to consistently keep stirring until the mixture becomes clear and thick. Once you're done, it should look a little bit like this. After cooking the mixture, spread it evenly on aluminium foil and let it dry for at least 2 days. After the plastic has fully dried, carefully peel it off the aluminium foil. You know it's fully dried when it's solid and it's transparent. So there you have it, that's your biodegradable plastic. Now at this point, you have the creative freedom to make it whatever you want. I used an iron and I made it into a little food packaging that we usually use in school canteens. But now, the big question is, does it really work? I decided to try an instant test on the decomposure of the plastic with bits and pieces I had left over. I boiled some water, poured it into a cup, and I dropped some pieces of the plastic into the cup. Then, for good measure, I give it a little stir. Within seconds, the solid plastic already softened, and as I squished it in between my fingers, it really turned into mush. And since the materials of this plastic is things that you usually throw down the drain on a daily basis anyways, it is safe for it to go in water treatment systems. Now for a food test.
It is time for epic cooking montage.
Okay, fries are done. Now it's time to put it in the bag and actually test it out. You know, for durability purposes, I kind of smacked it around, bent it, flipped it, flexed it and everything. Just to check its durability. I put the fries into the plastic pouch and surprisingly, it held up pretty well. The plastic was even see-through so you can actually see the food that you're eating. Now I was a little bit worried that the weight of the french fries couldn't hold, but surprisingly, it did pretty well. Now, how can we complete it without a taste test? Alright, now let's discuss. So what other materials can be used to make bioplastics? Well, we can use banana peels, orange peels, eggshells, and rice. So other than food packaging, what other objects can bioplastic replace? Well, bioplastic packaging options include bags for compost, agriculture foils, horticulture products, nursery products, toys, and textiles. They are also often used for disposable cups, salad bowls, plates, cling film, and food containers. No good alternatives comes without its disadvantages. So what are some of the challenges to replace regular plastic with biodegradable plastic? Well, first of all, crop-based bioplastics such as corn and rice require fertile land, water, fertilizers, and are reliant on weather conditions. This means that the supply of raw materials for bioplastics are at risk of natural phenomena such as drought. Most bioplastics need high-temperature industrial composting facilities to break down, and very few cities have the infrastructure needed to deal with them. As a result, bioplastics often end up in landfills where, when deprived of oxygen, may release methane, a greenhouse gas 23 times more potent than carbon dioxide. When bioplastics are not discarded properly, they can contaminate batches of recycled plastic and harm recycling infrastructure. If bioplastic contaminates recycled PET, also known as polyethylene terephthalate, the most common plastic used for water and soda bottles, for example, the entire lot could be rejected and end up in the landfill, which serves no purpose of recycling. Bioplastics are also relatively expensive. It can be 20 to 50% more costly than comparable materials because of the complex process used to convert corn or sugarcane into bioplastics. However, the prices are coming down nowadays as researchers and companies develop more efficient and eco-friendly strategies to producing bioplastics. So going back to our problem statement, is it possible for schools to practice sustainability by replacing traditional plastic? The answer is yes, it is possible. By replacing items such as food packaging with biodegradable plastic in schools, we can reduce the use of single-use plastic, thus reducing plastic pollution and practicing sustainability. Thank you, and that is all.
Meow meow! No! Meow!
No, kacau. No!